Hi, hola, ni hao, annyeong. Today, we are going to talk about the systems of linear equations. I am Carla J. Spuno from the BS Ed Mathematics, and I am assigned to answer the numbers 49 and 68 on the Chapter 1, Exercises 1.1 about the system of linear equations. Let's solve it. These are the numbers that I am tasked to solve. On the number 49, solve the system of linear equations. As we can see, there are three equations and there are three variables, which are the x sub 1, x sub 2, and x sub 3. On the number 68, state why each system of equations must have at least one solution. Then, solve the system and determine if it has exactly one solution or an infinite number of solutions. The given on the number 68 has two equations and three variables, which are the x, y, and z. The first item we are going to solve is the number 49. On this given, we can observe that there are three linear equations and three variables, which are the x sub 1, x sub 2, and x sub 3. To solve it, we can use the substitution method or the elimination method. For this given, I choose to do it using the elimination method. There are three equations, so the first step is to use the first and second equation and do the elimination process. I want the x sub 1 variable to be eliminated, so we multiply the second equation by negative 3 so that we can eliminate the x sub 1. And the second equation is now negative 3x sub 1 minus 3x sub 2 plus 6x sub 3 equals negative 9. And then we do the elimination process. 3x sub 1 plus negative 3x sub 1 will be cancelled and add the rest of the given. Negative 2x sub 2 plus negative 3x sub 2 will be negative 5x sub 2. 4x sub 3 plus 6x sub 3 is 10x sub 3. 1 plus negative 9 will be negative 8. And now we have the equation negative 5x sub 2 plus 10x sub 3 equals negative 8, and we label it as the fourth equation. Next, we do the elimination method for the second equation and the third equation on the given. I also want the x sub 1 will be eliminated for these two equations. So, we multiply the second equation by negative 2. And it will now be negative 2x sub 1 minus 2x sub 2 plus 4x sub 3 equals negative 6. And then do the elimination process. Cancel and add the other equation. And now we have negative 5x sub 2 plus 10x sub 3 equals 2, and we label it as the fifth equation. Fourth and fifth equation will be used for another elimination method. As we can see, both equations have the same sign and coefficient on the left side. We have the negative 5 and the positive 10. To eliminate, we multiply negative 1 any of the two equations. For this, I will be multiplying negative 1 in fifth equation. And the fifth equation will be 5x sub 2 minus 10x sub 3 equals negative 2. And now, we cancel, and negative 8 plus negative 2 will be negative 10. Now we have 0 equals negative 10. As we can see, 0 is not equal to negative 10. This equation is labeled as sixth equation. The sixth equation is a false statement, which is 0 equals negative 10. Therefore, this system has no solution. it is an inconsistent system. The next item to solve is the number 68. Directions state why each system of equations must have at least one solution. Then, solve the system and determine if it has exactly one solution or an infinite number of solutions. Based on my observations and research about the exercises 65 to 68, each system of equations must have at least one solution, since they are all homogeneous equations. A system of linear equation is said to be a homogeneous if it ends with a constant 0, if all the coefficient on the right side is 0. Every homogeneous linear equation always has at least one solution. Therefore, all the exercises 65 to 68 has at least one solution and or can have an infinite number of solutions. So we conclude that all these items has at least one solution. This is the given on the number 68. As we can see, there are two equations and three variables, which are the x, y, and z. Again, we can use the substitution method and or the elimination method. For this given, first I use the elimination method and then the substitution method, since there are only two equations given. As we can see on the first and second equation, we can now eliminate the variable x, since they have the same coefficient but different in the sign. So we cancel, and then 12x plus 12x is 24x, 5y plus 4y is 9y and equals to 0. And then we move the 9y on the right side and it will be negative. So we have 24x equals negative 9y. And then divide both sides by 24, cancel, and now we have x is equal to negative 3 over 8y. Then substitute the equation of x to the first or second given equation to find the value of y. I use the first equation to substitute the x. Now we have 12 multiplied by negative 3 over 8y plus 5y plus z equals 0. And then distribute. Now we have negative 9 over 2y plus 5y plus z equals 0. And then we do the combining like terms. We add the negative 9 over 2y plus 5y. And then we move the variable z to the right side. And now we have 1/2 y equals negative z. To get rid of the denominator, we multiply both sides by 2. So we cancel. And then now we have y is equal to negative 2z. Then substitute the value of y to get the value of x. I also use the first equation for this. And now we have 12x plus 5 multiplied by negative 2z plus z equals 0. Now we have 12x minus 10z plus z equals 0. And then combining like terms. 12x minus 9z equals 0. And then we move the negative 9z to the right side. And then we have 12x equals positive 9z multiplied both sides and then divide both sides by 12 and then cancel. And now we have x is equal to 3 over 4z. And then substitute the value of x and y to get the value of z. I also use the first equation for this. Now we have 12 multiplied by 3 over 4z plus 5 multiplied by negative 2z plus z equals 0. Now we have 9z minus 10z plus z equals 0. And then combining like terms. And then we got 0 equals 0. And it says that the equation is true. To represent the solutions, set variable z to t, where t is any real number. So x will be 3 over 4t and y will be negative 2t. And then we got all the values for the three variables x, y, and z. We have the 3 over 4t, negative 2t, and t. The given system of equations has infinitely many solutions. Thank you. Again, I'm Carla Joyce Puno from the BS Ed Mathematics.